If you like the video, please subscribe Technical PCT channel and click the bell icon to get the latest videos.
Electrochemistry, right? See, in this electrochemistry lesson, actually, it's a very big lesson. In our total track 1 syllabus, the biggest chapter means electrochemistry only. In this one, let us see what are the important concepts we are going to study. Those are the first one, electrochemical cells. Electrochemical cells. The next one, conductance. The next one, see Faraday's laws. One more name is there, electrolytic cells. Lastly, see batteries and corrosion. Yeah, these are the important concepts what we are going to study. This, okay. Let us go through each everyone now. See the just preliminary concept on each one. The electrochemical cells. Electrochemical cells means, say, in our mobile, we are having lithium ion battery. Is it not? So that one. And then the very famous one you might have observed, that is, say, the torchlight cells. So that torchlight cells also, suppose a bigger one you take, the little bit, bigger one you take. So that one, see, it works for some time. It costs around nearly some 12 rupees or 13 rupees like that. See, then, see, after once it is used, when it get exhausted, and then where we say that power is completely gone. So at the time, generally the children, what I am saying, what they do, they will take, see, but the batteries, that means those cells, the cells which are thrown out, in our childhood also, definitely you might have played. Okay, so the children, what they do, they collect those, and then, see, taking a stone, and then they will be stacking, okay, and then they will open it and see. They will open and see. And for see, it can be used for as a play toy also, actually, by the children, right? Then, see, definitely some of you might have broken. See, sorry, some of you might have, see, the opened that cell. In that one, what do you find? A black rod you will find. Is it not? A black rod, and then, see, for that a circular one, plate type, that is attached. Is it not? Then the other end also, one more, the circular plate, okay, round shaped plate, that also will be there. And then, see, black mass will be there inside. Black mass, that also. Definitely, so many of you might have found like that. So now, that black mass I am saying, as well as that black rod, it is nothing but carbon rod. So some chemical is present inside. Is it not? Some chemical is present inside. Therefore, what you can say, see, the chemical, and then what is the use of that battery? It produces current. Is it not? Electricity. So there, by using the chemicals, we are producing electricity. By using the chemicals, we are producing the electricity. So remember, that is right. Yeah, then in first one, we are going to discuss that. That means what kind of, see, what's up? Simply any chemical is put in that. Can it be able to generate electricity? No, not like that. Particular. So, what are the principles and what is the phenomenon involved there? We have to discuss, because you just see for different purposes, different types of the cells are available. Is it not? So, in our mobile lithium ion battery, Then see suppose remotes and all those the small batteries. In that small also medium size, then bigger size like that. Even still more bigger size also available. Right. And again among them also see you will be finding cheap quality only once they can be used, and then see only once. Whereas and then if you see if you afford a little bit more amount, then rechargeable batteries also available. So therefore, what is the principle involved in that? That also we have to see. Right. So in that one, the first one. Next one, conductance. See the conductance in the sense, say the Ohm's law and those. In a say it is purely physics part. Of course, the chemistry touch will be given to that. In the second one, I am saying. The next one, Faraday's laws or electrolytic cells. See, the first one is called as the electrochemical cells. The third one, electrolytic cells. You are observing. Is it not? Electrolytic cells, and another name is Faraday's laws. Faraday's laws. There, electricity will be passed into the chemical. Electricity will be passed into the chemical. You just see, it is just reverse to the first one. It is just reverse to the first one, I'm saying. Right? Yeah, then, see, the next one, lastly, batteries and corrosion. So, see, already for electrochemical cells means we have said batteries, but again, see, batteries came. See, listen, those electrochemical cells in different manners we will be using now. So those are the batteries. Those are the batteries I'm saying. The another one, corrosion or corrosion. Yeah, see about that also. Rusting and all those. So there we discuss. These are the important points. See the concepts to be discussed in this chapter. See, important chapter, minimum two, sometimes even three and four also, the questions will be given in the examination. CET definitely minimum two or three, minimum that will be what I'm saying. And then see the NEET as well as the JEE mains you consider, see minimum one, and even sometimes in NEET two questions also will be given. And moreover, I said now easy chapter. See in this one, the difficult topic means the first one, just slightly electrode potential, that new concept will come. So little bit you will be feeling, but I'm sure that I will make you to feel very easy. Right? Just you have to listen carefully. Right? See the important chapter. And then the first year chapter, basic concepts in chemistry, stoichiometry is there now. That is involved here also. Again. That is again involved in this chapter. Okay, so now let us discuss about the first one, electrochemical cells. Right? Yeah, that is, let us take them. Electrochemical cells. See, these electrochemical cells also called as some other names. See, voltaic, right? Otherwise, galvanic cells. Galvanic cells, voltaic, otherwise the galvanic cells. They are also called as. And then uh, the example for this, the very famous example, even in your first year also, you have studied that. Right? Let me take that. The example for this, what we are going to discuss is Daniel cell. Daniel cell. Daniel cell. See now the Volta and then Galvani. See the two are names of scientists. Remember, names of scientists. They worked a lot on this. So therefore, these electrochemical cells also called as voltaic cells, galvanic cells. For them, the best example is Daniel cell. Because in first year also we discussed that. Daniel cell. Yeah, first of all, electrochemical cell means, remember, chemical energy will be converted into electrical energy. So please remember, see, chemical energy is converted into electrical energy. Okay, chemical energy is converted into electrical energy. That is so. In this one, chemical energy means chemicals. So that those chemicals, particular chemicals, they should be taken in this device. So this device is such that it converts. Okay, otherwise it performs some reaction with that chemicals and produces current. So therefore, that current only will be used for different purposes. I'm saying. So chemical energy is converted into electrical energy. Now let us see. Volta, the Galvani, the names of the scientists. See, these two scientists actually, majorly, they worked a lot on this. Listen, see, in their research work, what I'm saying, see what happened. Nah? They were doing some work on some other thing. Not exactly they have taken this heading and doing this. Not like that. They are performing some other thing. Right. At that time, see, they need of sunlight. But rainy season, just like now. Rainy season. So therefore, what happened? Nah? Accidentally, see what happened? The copper plates and then zinc plates. Copper plates and zinc plates were happened, okay, to be, see, they were placed in a table drawer. That's all. Okay, just so what happened, you just see, the copper plates and zinc plates together were kept in a table drawer, right? Then rainy season, I am saying. Rainy season means definitely the hands were wet. I'm saying. So what happened now? When they came to that table, near the table, opened that table drawer, then when they touch the copper and the zinc plates, they felt, see, they felt shock. See, the shock in the sense electricity, is it not? The shock in the sense electricity. See, what happened now? When they see, they felt the shock now, therefore no electricity. Just zinc plates and copper plates and hand wet condition. The hand wet condition, I am saying. Therefore, see, they thought that copper plate and silver plate, as well as wet condition. See, wet condition. So these three, copper plates, zinc plates, and wet condition, will produce, because when they experienced shock means current is there. So electricity can be generated. So they worked on that. And constructed Daniel cell. I'm saying. So now here, the Daniel cell, let me take the construction of the Daniel cell. See, Daniel cell, in this one, let us see the construction of the Daniel cell and let us see how, see, it works. And then what is the voltage produced by that cell. Okay, so now here in this one, yeah, you just observe now. This is a vessel type. So in this one, zinc rod is suspended. So then here, like this, the solution is there. So now let me say, this is zinc rod. This is zinc sulfate solution. Right? Zinc sulfate solution. Now, This is connected. Yeah, then another vessel type. So in this one, like this, right? So this is copper rod and then copper sulfate solution, copper sulfate solution, then like this. These two are connected like this, just simply a copper wire vessel. Okay, like this. It is the way. So now you see, this is the way. Okay, now this one is zinc electrode, you call zinc electrode. This is called as copper electrode. Copper electrode. Okay, copper electrode. You see, zinc electrode and then copper electrode. It is the way. It is the way. Now, what happens? Let us see. Zinc electrode. There, zinc rod, zinc rod, zinc rod. Okay, this is the arrangement. This is the arrangement I am saying. This is the arrangement. So, see, observe this carefully. Right. Zinc rod, zinc rod. Zinc rod is made from zinc atoms. Na? Zinc rod is made from zinc atoms. So, those atoms lose electrons to the rod. Those atoms lose electrons to the metal rod, and convert to Zn2 plus ions. See this reaction, is it oxidation or reduction? Loss of electrons. Loss of electrons is called as oxidation. So, oxidation. So, oxidation occurs at anode. Oxidation occurs at anode. That is. Yes, then next one. See, these electrons will travel like this. These electrons will travel like this, I am saying. This is the way. Is it not? The electrons will travel like this. And then here, copper rod. Copper rod is there. Copper rod is made from copper atoms. And in this solution, this is copper sulfate solution. Copper sulfate solution. So, Cu2 plus ions gain that electrons and convert to Cu. So, this is reduction. This is called as reduction. Reduction, that is called as reduction. So, oxidation and reduction. Please remember, oxidation occurs at anode. Oxidation occurs at anode. Reduction occurs at cathode. Remember. Okay. Reduction occurs at cathode. Now, this is zinc electrode. At the zinc electrode, oxidation is taking place. Therefore, it is anode. So now here, zinc electrode is acting as anode. Copper electrode is acting as cathode. Remember. Next, one more thing. We have to give the sign. We have to give sign, I am saying. Positive or negative. Now, at anode, you please see. At anode, what is happening? What's happening at anode? So at anode, yeah, oxidation is taking place and electrons are left to the rod. Therefore, compared to solution is neutral. Solution is neutral, I am saying, because Zn2 plus SO4 2 minus, overall neutral. But the metal rod, negative charge, because electrons are left to the metal rod. So, anode is denoted by negative sign. Remember. So, in electrochemical cell, anode is denoted by negative sign. Remember, negative sign automatically C automatically. Now this is compared to solution. Okay. Now you come to the copper rod. A copper rod I am saying. So see here the solution there. Here, see this is negative sign now. Here, see opposite to this. So positive, that is positive. So therefore, please remember, see in this one, what is happening, ma? See, electrons. Those are moving from zinc rod to copper rod, zinc electrode to copper electrode. Zinc electrode is given by negative sign. So negative electrode to positive electrode. See, remember one more important thing. What about the flow of current? Flow of current. It is always opposite to flow of electrons. Electrons are moving from left to right here. That means negative electrode to positive electrode. The electrons, they are moving from negative electrode to positive electrode. Please remember, negative electrode to positive electrode. Then what about the current? Say, the current flow will be opposite. Please remember this. In entrance examination, they will be asking like this. Electrons flow, negative electrode to positive electrode. Current flow, positive electrode to negative electrode. So please remember this. This sign, negative sign, positive sign, most important, most important. Many times the question on this. Okay, so the electrons flow and current flow always opposite in direction. They will be. So you please remember in electrochemical cell, see the anode is denoted by negative sign and cathode is denoted by positive sign. Please remember like this. Now, the net reaction. So plus you do. Electrons get cancelled. Is it not? Electrons get cancelled. So what do you write, ma? Zn, okay, solid plus Cu2 plus aqueous gives rise to, say, Zn2 plus aqueous, right, plus Cu solid. This is. So now this is you call as cell reaction. This you call as cell reaction. So therefore, how do you get the cell reaction? Very simple. Say anode reaction plus cathode reaction. Please, what and all the steps I am doing, you have to practice in the same way. That is, in the same way I am saying like this. Okay, in the same way, that is. So remember like this. Understand? Yeah. So overall, this is like this. Still, it is not yet over. It is not yet over. See, Daniel cell means like this. But in this arrangement, see, one more, we draw like this. A U-shaped glass tube we will arrange. U-shaped glass tube, that is. Now let us see what is the meaning of that and what is the importance of that. See, that is Daniel cell we are discussing. Understand? That is the Daniel cell we are discussing, I am saying. Right? See here, see, the zinc atoms, they lose electrons to the metal rod, enter into the solution as Zn2 plus. Now see here. See, in this arrangement, right? Just like this. In this one, see, in that solution, you will find Zn2 plus SO4 2 minus. Zn2 plus and SO4 2 minus. Is it not? Whereas, see, now let us see whether it functions continuously or not. Okay. See, in solution, this is the solution. This is the solution. Zinc sulfate solution. So in that solution, what do you find? Zn2 plus ions and SO4 2 minus ions are there. So plus 2 minus 2. Plus 2 minus 2. So is it a neutral or not? It is a neutral solution. Is it not? It is a neutral solution. Now, anode. What is happening? Zinc atoms from this metal rod, zinc atoms, they lose electrons to the metal rod and enter into the solution as Zn2 plus. They enter into the solution as Zn2 plus. So now, in solution, what happened? Zn2 plus number is increased. Now, at this condition, do you say the solution is neutral? No, you can't say because see, the plus is increased, minus less. Okay, so comparatively, overall here you can say positive charge. Solution, its neutrality is disturbed. And come to here. See in this one, copper sulfate, Cu2 plus, SO4 2 minus. Cu2 plus and SO4 2 minus ions are there. Is it not? So here, see at cathode. So here copper electrode is acting as cathode. Copper electrode is acting as cathode. So see the Cu2 plus ions from the solution. Cu2 plus ions from the solution gain electrons from the metal rod, and reduced to copper metal. That means they get deposited on copper. Rod. Therefore, what happened? Cu2 plus ions are disappearing from the solution like this. So, initially, this is a neutral one. Is it not? It is a neutral one, I am saying. It is a neutral one. It is a neutral one. But what happened now? Neutrality is disturbed. Here. So therefore, see, neutrality is disturbed here. Therefore, negative charge is developed. Their positive charge is developed because like this and this is. Therefore, what happens now here? See, the Zn2 plus, they will be accumulated here because the solution does not allow, to get disturbed of its neutrality. Even here also the same thing. So what happened? Here Zn2 plus accumulation around this. Here also SO4 2 minus accumulation. That means crowdiness. Right? So therefore, see the accumulation of charges take place. Therefore, the linear cell stops functioning. Why? Because the electrical neutrality of solutions, ZnSO4 as well as CuSO4, get disturbed. Is it not? Get disturbed. Next one. See, next one. The accumulation of the charges, meaning ions around the electrodes. Okay, so accumulation of charges near the electrodes, take place. Okay, therefore, cell stops functioning. That means it does not produce electricity. It does not produce electricity. Therefore, now how to make the cell functioning continuously? How to make the cell functioning continuously? For that, what we have to do? Sir, we should see that accumulation should be cancelled. The neutrality again regenerated. Very simple. See, at that time, we use salt bridge. We use salt bridge. That is, see, the salt bridge. Salt bridge, I am saying. Now here, see, so what happened now? When salt bridge is not there, the accumulation of charges near the electrodes take place. Is it not? Takes place. Yeah, then say salt bridge will be used. So now let us have a discussion on salt bridge. See, salt bridge. It is a U-shaped tube, is it not? It is a U-shaped tube. It is U-shaped tube. In this one, what and all present? See, agar, gel will be there in this one. Agar, gel. Plus KCl, KNO3, NH4, NO3. Electrolyte also will be present. So please remember, in that one, what do you find, ma? What do you find? Say, agar gel plus KCl, KNO3 or NH4NO3. Electrolyte also must be used. Let us see what is the use of this electrolyte. And also one more thing. Next one. Suppose a student can question, sir, NaCl is there now very cheap. Why don't we use? No. These only must be used. These only must be used. Let us see. See one thing. What happened now here? See, at a zinc electrode, Z and 2 plus are more in number, right? The positive charge is more. Therefore, so at the time, what happened? See, at that time, see, now that should be neutralized. That should be neutralized. I am saying that should be neutralized. Therefore, see, in this one, Cl minus or NO3 minus, Cl minus or NO3 minus will travel into the solution. Therefore, neutrality will be developed. Next one, another one. See, another one. Next one. See, here SO4 2 minus are more in number. Is it not? In copper electrode, what do you find, ma? SO4 2 minus. SO4 2 minus are more in number. Therefore, see, so minus, negatively charged, those are more in number. Therefore, they must be neutralized. So at this time, we need plus, positive. So K plus or NH4 plus, K plus or NH4 plus will enter into the solution. So neutrality is maintained. And also next one, what about the accumulation of the charges? No accumulation. So see, the accumulation of charges is prevented. That is, understand? That is, therefore, what will happen? See, electrical neutrality is maintained. Next one, accumulation of the charges, that also, see, avoided, prevented. Therefore, cell functions smoothly. So please remember here. Next one here, see, of course, it is. Yeah, then, next one. Why these only? Because, see, here, at a time, simultaneously the things should happen. That's why K plus and Cl minus. So mobility, okay, of K plus is equal to Cl minus. Okay, so therefore K plus or NH4 plus, it is equal to Cl minus NO3 minus. So their movement is same. Movement is same. With the same velocity, they move. Suppose if you take some other ionic compound, see at that time, see the mobility of cation and anion will differ each other. So therefore, we have to take an electrolyte such that they should move. They should move with same velocity. They should move with same velocity. Please remember, they should move with same velocity. That's why these electrolytes are used. So anyhow, see, you can take the screenshot of this. Screenshot I'm saying. Okay, screenshot I'm saying. So what is the use of salt bridge here? You can say that is, see, you can say like this one. See, electrical neutrality of solution maintained. Is it not? And also, next one more. What do you say? See, the accumulation of charges, accumulation of charges near electrodes prevented. Okay, that is. Please remember, it is a U-shaped glass tube, and then in this one agar zel, and then KCl or KNO3 or NH4NO3 will be used, right? Like this. So why that particular electrolyte you will say? You will say that the mobility, speed of cation will be equal to speed of anion. That is right. So that is, yeah. Then overall, this is electrochemical cells. Electrochemical cells. Electrochemical cells are also called as voltaic or galvanic cells. The best example for that, Daniel cell. Daniel cell. So what is the function of electrochemical cell? See here in this device, see, chemical energy is converted into electrical energy. So Daniel cell construction. Zinc electrode, anode, denoted by negative sign. Then copper electrode, cathode, denoted by positive sign. Okay, always remember anode, oxidation, always remember that. So this is, and then flow of electrons from negative electrode to positive electrode. What about current? Current flow opposite now. So positive electrode to negative electrode, like this. Then see, to generate electricity continuously in this cell, we use salt bridge. Salt bridge, U-shaped glass tube. It contains agar gel plus KCl, KNO3, NH4, NO3. So the why that particular electrolyte only is used? See, the reason is, you can say, the mobility of cation will be equal to mobility of anion, because at a time they have to enter into the solution and they have to maintain the neutrality, as well as see what happens because of the salt bridge. Electrical neutrality in the solution will be maintained. Next one, accumulation of charges near the electrodes will be prevented. So thus the cell continuously produces current. Okay, about this. Tomorrow, see, we can continue this one, right? On this. Then about this one only, we have to go through. Please remember, don't miss the class, because most important chapter, Then little bit see this first part, especially the difficult also. The problems will be in different manner they used to give. Of course, definitely I will discuss the important problems present in our material. I think almost all of you might have received the material because I have seen in the college also so many students daily they are coming and collecting the material. I do not know the others still. Okay, so you please collect all those. Yeah, okay. Yeah, thank you all of you. Tomorrow I will meet you. Good day. Bye bye.